of quadratic functions. Now, by now, you know what a quadratic function is, right? When you sketch the graph of a quadratic function, it looks like a U shape, right? And it's either concave up or concave down. We also know that when we are going to sketch the graph of a quadratic function, we need to first determine, right, what the y-intercept is going to be, what the x-intercept is going to be,
the vertex.
Also the vertex, and
Axis
we
of
also
symmetry.
need to identify the axis of symmetry in the graph, right? Now, how do we determine the vertex if the function is in standard form? We use a little formula for that, right?
Yes.
And the little formula to find the vertex if the quadratic function has been given to you in standard form is this one, right?
Negative
Minus b over 2a, comma, the function evaluated at this value. Are you following?
Yes.
Okay? Alright, perfect. Now, this is to find the vertex if the function is given to you in standard form. Now, if the function is given to you in vertex form, you can simply identify what the vertex is from h and k. Is that right? Okay, perfect. Now that's for the vertex. What about the x-intercepts? How do we find the x-intercepts, right, of a quadratic function in standard form? We identify a, b, and c, and we use the quadratic formula. Exactly. Now, if you can factorize, you go ahead and factor it out. But if you are unable to factor the trinomial, then just go ahead and use the quadratic formula. Are you following?
Yes.
And the quadratic formula goes like this. X equals, and this is the vertex,
Negative
and this
b
is for the x-intercepts. X equals
Negative
negative b
b
plus or
plus
minus square root of what?
4b
B
as a
squared
b squared
minus
minus
4ac
4ac
times c all of that divided by
2a.
2a. Alright? That's to find the x-intercept, right? Now, we also needed to determine what the y-intercept, right, was going to be. And to determine the y-intercept, regardless of what form the
You put
function
x in
is in,
zero.
you just put 0 in x. X in 0, but 0 in x. Exactly. And then you just see then what you get after simplifying. The number you get, that's going to be your y-intercept. Is that clear to you?
Yeah.
Okay? Now, what we're going to start studying this week is applications of quadratic functions. So we're going to be looking at context, right? And word problems. So the paper that I gave you has 9 word problems, and I'll be starting with problem number 1. Okay? So understand the following, guys. If you throw something in the air, right? I gave you at the beginning of the year when I was explaining to you what a function was. If I throw the eraser like this, right? The shape of the movement of the eraser in the air is a parabola. So we can definitely use quadratic functions to model the movement of the eraser in the air. Does that make sense to you?
Yes.
We can use the quadratic functions to model projectile motion or anything that's moving in the air, right? Now, what are we relating in a model, right? Or a quadratic model for the movement of the eraser in the air? We are relating the height or the position, right, with respect to time. So as time passes, the height changes. Do you understand? Because of course, when I threw, right, the eraser, you notice the height starts to change. It starts to increase, go up,
And then
it comes back down, right? Exactly. It reaches a vertex or reaches the maximum height, and it starts to come back down, right? Why? Because of gravity. Because of gravity. Now, in physics, all right, in physics, actually in physics, this is studied all based on math, right? And the understanding of quadratic functions, right? But in physics, the vertex has a meaning, all right? The x-intercepts have a meaning. The y-intercept also has a meaning. So we see the application of these mathematical concepts in physics, right? So that's why when we study applications of quadratic functions, we look at a vertex, or we look at the vertex in a different way. We just don't see a vertex, but we see a maximum height, right? Yes or no?
Yes.
It makes sense to you, right?
Yes.
We don't just look at what the highest point is anymore in the parabola, but we give it a meaning. And the meaning to the vertex is now that it reaches, that's the highest point of the object that we're studying or modeling. Does that make sense to you?
Yes.
Okay, so let's take a look at problem number 1. It says Eric is at the top of a cliff that is 500 feet from the ocean's surface. Okay? So I'm going to sketch a diagram, a little diagram. I'm going to draw that situation. I'm going to leave these formulas here. And imagine Eric is here. This is a cliff. That's the water. And it says here that he is at the top of a cliff that is 500 feet from the ocean surface. So we could say, well, this height here, this total height is what? 500 feet. So FT here. And it says he's waiting for his friends to climb up and meet him. As he waits, he decides to start casually tossing pebbles off the side of the cliff. The equation that represents the height of his pebble tosses is S equals, I'm going to write the equation that models the movement of the pebbles in the air. The equation is the following: S equals minus t squared plus 5t plus 500. Okay? Now, the equation that represents the height of his pebble tosses is this one, where S is what?
Seconds.
S is? It says it's there. It's distance. And T is?
Time.
Time in seconds. Now, distance is measured in feet, right? Now, understand the following. This here, guys, is just a little model, right? It's a model, a mathematical model that allows us to understand or to see where the pebble is at a given time, okay? It's this function has been given to you to answer the questions. Is that understood? So now let's take a look at the first question and analyze it together. It says, how long does it take the pebble to hit the water? Now, here is our friend Eric. Eric is up here. And he's tossing pebbles, so the movement of the pebble is something more or less like that, right? That explains the why our function is negative, right? It is a concave down parabola. Does that make sense to you?
Yes.
Now, what we're trying to find out in the first question is the time it takes for the distance to be 0. Why is that? Because they are saying, well, how long does it take the pebble to hit the water? Do you understand?
Yes.
Okay? So when the pebble hits the water, considering we're using the surface of the water as the ground, right, or 0 level, okay, we understand that that's when the height is 0, right? So when the height is 0, what is or how much time has passed? Now, having the function, right, this function over here, and understanding what S and T mean, right, and we mentioned it before, S is what? The distance, and T is what? Time. Now, I'm going to ask you, what's the independent variable here?
The
It's obvious.
distance. Time.
Time is independent, right, and distance is the dependent, because as time passes, the distance changes. Does that make sense? So would we plug in 0, considering that we have been told in the problem that when the pebble hits the water, will we plug in 0 in T or S? In S, obviously, because they're saying that what is T? You need to find what T is when S is 0. Does that make sense?
Why is 0?
Okay?
Why 0 for
Because
That
that's
would be
when the
making the
pebble
Y
hits
0.
the water.
That's the final.
So what's T when S is 0? Does that make sense?
Yep.
All right. So this means that to answer A, I'm going to say A, 0 equals minus t squared plus 5t plus 500. Right? Now, any questions so far? Now, this is a beautiful quadratic equation that we can definitely work with. Using the quadratic formula, we can go ahead and find what the values of t are. right?
Yes.
What's A, guys? What's A?
T squared, negative T squared.
-1. What's B?
5.
5. And what's C?
500.
500. So we say, well, T is equal. We're not calling this x, but we're giving it a mini. We're using T for time. Time is equal to -5 plus or minus the square root of B squared. So 5 squared minus 4 times A times C. 500. All of that divided by 2 times A, which is -1. Okay? So when we do that, what do we get? Someone please, using the calculator, find out what the number inside the radical, and even if you can apply the square root, go ahead and do that for us and tell me what you get. Okay?
Is there a way to do plus minus on the calculator?
No, okay, so remember that you cannot put the whole thing in the calculator.
Just put the what's
Just
inside.
do it by parts, right?
Sí.
Now I want to be fair to you guys and mention something important because you might know this from your friends upperclassmen. So there is a way that the calculator can get you both values of x given the quadratic form, the standard form of the quadratic function. You can just go to apps 9, 1 and it gives you the values. However, I want you to understand that you're required to show work for this, and that's why you have to use the standard for this level is the student is able to use the quadratic formula to find the values of x. So you want to show me all your work using the quadratic formula. Is that understood? Okay? You can use the other method using apps in the calculator to check your work, but you have to show your work using the quadratic formula. Now, did you finish? Did you get the values of t?
Yeah.
How much?
Did everyone find the values of t?
Yeah. Square.
Just one number.
What is it?
25 negative.
Okay.
Square root of 5.
What is that?
We have also
45.
5.
So
So
We
negative
have
5 plus minus 45.
negative
Okay.
5 plus.
Now, I don't know about you, but I got that t is -20 and 25. Is that what you got?
Yes.
Okay.
No.
Now,
Sí.
obviously, time cannot be negative, so we disregard this value of t and we stick with this one. Now, is this in hours, days,
Seconds.
seconds? So 25 seconds. So, and it's important, guys, since we're working with application problems, you need to give me a full sentence as an answer. Is that understood?
It would take some time.
Exactly. So the pebble, it would take the pebble 25 seconds to hit the water. Does that make sense?
Mr.
Any questions? Yes.
When I did the inside, I got 45.
Yeah, you didn't divide by 2.
But
By -2.
So we divided by -2 after.
No, you get listen, you get this value here, right? You add and subtract separately -5, and then separately also you divide by -2, and that should get you these two values over
But
here.
it would be -25, no? Because if it's 45 plus
Negative over
it's
-2.
40.
Yeah. Any questions about A of this first problem? Questions?
¿Cómo se contestaría?
Todavía, if it's adentro es 45, menos 5 is -50, divided by -50.
¿Cómo se escribiría el answer?
How would you write the answer? The answer would be, think about the question. What does the question say?
What if they're both positive?
That could happen in certain contexts, and even guys, listen. Right now, we are solving for the time it takes to reach the maximum height, right? Right? Okay. So the obvious answer is the 25, and the other one is obviously not the answer because it's a negative number. Time cannot be negative. Now, in some contexts, if I give you, for example, a question that says, at what time will the object be, or the ball be at this given height? You will get two values of t, and they will both be positive. They're both valid answers, and I will explain to you those problems too. So for now, let's just keep the stay in context, and that's the answer for A. Does that make sense? Now let's take a look at B. B reads. Can someone read B out loud? What does it say?
B says if 15 seconds have gone by, what is the height of the pebble from B?
Beautiful. So we go back to our original function. they are telling you the time. Are they telling you a distance or a time?
Time.
A time. So what do you have to give them? Read the question. Read the question.
The height of the one.
Exactly. They are giving you time. You have to give them what?
Distance.
The distance. So in other words, it says, if 15 seconds have gone by, what's the height of the pebble from the ocean, right? So, okay, so what do we do?
We put S at 15.
S of 15? Are you
T at
sure?
15.
They are giving you time.
Plug in 15 for the
Plug in 15 for the what?
For the
For the t, because 15 is time. Read the question. It says 15 seconds, right? So for B, I'm gonna do B here. B. Okay, and B is down here. B, I'm going to do, well, S is equal to 15 squared. Does that make sense?
Negative 15.
Negative
Bueno, no
15
importa, es lo
squared
mismo.
plus 5 times 15 plus 500, right? Okay, so go ahead and do that math and tell me.
560.
560?
I have a question. So there, because the negative sign is outside the.
You do the power first.
You do the power first and then you
Apply the negative.
right.
Exactly.
So that's where you get it from.
Wait.
Okay, be careful there. You do the power first. What did you get?
350.
350. 350. So what would the sentence be for the answer?
350.
Guys, how would you answer?
The distance after 15 seconds.
After 15 seconds have passed, the height will be 350 feet, meters, feet. All right, use the right units. Any questions? Okay, good. So what about C? It says, what is the highest? Did everyone understand A and B?
Yes.
Okay, let's take a look at C. What's the highest point of the pebble? 1 second. What is the highest point the pebble will go? Yes, Luis.
It's actually the thing about A. I know this is it's like it doesn't really matter which strategy you use, but like for A, what I did is I plugged the formula into the calculator, and then using the
Apps.
What was it? It was the trace function. Yeah. Using trace, I went down to
Yeah.
the closest value.
Totally.
And then I plugged in. I checked 24 and 25, and I figured out that 25 was correct.
That's right.
So, yeah, I used.
You're using tracing. You're tracing in the calculator, right?
So,
Okay,
I think
listen.
that they had
Listen.
Is that like a valid way to do it? Or-
Yeah, no, you have to use the quadratic formula. That's what I mentioned before. Yes, you can use the calculator can help you prove this and check your work, but you have to use the quadratic formula. Now listen, I have good news for you. That's only for 10th grade. Next year, if you take AP pre-calculus, you use whatever it's easier for you. Is that understood? Okay? But at this point, you have to demonstrate you know how to use the quadratic formula and know how to factorize. Does that make sense?
Yeah.
Any questions? Any questions on that? No? Good. Let's go to C together. C reads, what is the highest point the pebble will go? Okay, the highest point the pebble will go. So doesn't the question kind of
It's a
tell you
vertex.
there? The vertex, exactly. Now, for that, we would have to use the little formula for the vertex, don't we? Right? Now, listen up. The vertex has the vertex is a coordinate. Do we all agree on that?
Sí.
It's a coordinate. It has a value of x and it has a value of
Why?
y. Now let's give meanings to both the value of x of the vertex and the value of y of why are you talking? Let's give meanings to both the x of the vertex and the y of the vertex. The x of the vertex is a value of time or distance.
Distance.
Time.
Time, because we'll be
X is
using
time.
right. X is time in this context.
Remember, S is distance, S is Y.
Exactly.
T
Now,
is X.
the y of the vertex, we said the vertex is a coordinate. The y of the vertex is it a value of time or distance?
Distance.
What of x or
Y.
y?
Distance. So, which out of the two is the x of the vertex going to give you the highest point or the y? The y. Okay? But what does that time in the vertex mean? It means the time it takes to reach the maximum height. Is that understood? If I were you, I would write that down because the students forget that all the
Can you
time.
repeat it?
Okay? Yeah. The x of the vertex is the time it takes to reach the maximum height. Okay? That's the x of the vertex. It's a time value. Already?
After the vertex is the maximum time.
The x of the vertex is the time it takes to reach the maximum height. And the y of the vertex is the maximum height.
The maximum.
Yeah, the distance or the maximum height.
The
Does
y,
that make sense?
The y of the vertex.
The y of the vertex. You want to write it down? Okay? Very good. Did you write it down?
The y of the vertex is the distance.
Yes.
Yeah. Or maximum height. You can just call it maximum height. Because it's a distance, right? A vertical distance. Any questions on that? Okay, good. Now that we have to answer C for this problem, it says, what's the highest point the pebble will go? Now let's think, okay? In order to determine the highest point the pebble will go, we will first have to determine the time it takes to reach that maximum height. So the value of x. In other words, we would have to use this little formula, minus b over 2a,
Yes.
to get that time. Once we have that time, what do we do with it? Once we have this time,
You plug it
you
into
plug it into the function, and then what you would be getting afterwards is the maximum time. Okay? How do you feel about doing it by yourself?
Easy.
Okay, go ahead and do it. Do it. If your amiguito Pio Pio, the person sitting next to you, doesn't get it, explain it to them. Explain it to them.
Is it 506?
Oh, I got that.
Oh, you want us to see?
See, exactly. What's the highest point we're going to do?
It's the same as
Did you get 2.5?
Yes.
Yeah, sure.
Okay. Very good. That's the time it takes to reach what?
The maximum.
The maximum height.
Like a square.
Now we do
No,
distance is
yes,
equal
yes.
to okay. Now go ahead and plug in that time value into the function. See what you get for S. What did you get?
506.2.
Yeah, I got it right.
500.
And 6.25.
Is that what everyone else got?
Yes.
Okay. Feet. What would the answer be?
The highest, the maximum height of the pebble.
Listen up. Okay, yes?
The maximum height that the pebble would reach would be 506.25.
Does that make sense to everyone?
Yes.
Yes.
Yes.